Bioeconomies. This is the third webinar of the City Interest Group webinar series, and it's hosted by the Circular Biocarbon Project. My name is Nestor Guisasola, and I'm part of ICLEI Europe's Circular Economy team. Today, I'm joined by my colleague John, who will ensure this webinar runs smoothly. ICLEI is a global network of local and regional governments committed to sustainable urban development. We work for cities and regions and with cities and regions. We do so by engaging in advocacy, developing and exchanging knowledge, and building capacity through a series of projects. And for this particular project, for Circular Biocarbon, ICLEI leads communications and is managing the City Interest Group, driving efforts towards the replication and exploitation of project results in cities and regions. So this is the agenda for today's session. As you see, it's a pretty packed agenda. To begin, we will set the stage by exploring the circular biocarbon biorefinery approach, highlighting its role as a key enabler of urban bio-based economies. Next, we will hear from Michael Pham, CTO of Semicon Scandinavia and one of the project partners. Michael will discuss how to transform carbon from complex urban waste streams into added value products, focusing specifically on the bio-based coatings they develop. Following the presentation, we will hold a brief Q&A session with him. In the second part, Pierluigi Argonetto, consultant for the Italian Bioeconomic Cluster Spring and coordinator of the BioINSouth CBE project, will share his insight. Pierluigi will provide a broader perspective on fostering regional bio-based economies through various mechanisms such as CAPs and policy innovation. This session will also include time for questions. And we will conclude with a discussion segment and aim to finish by approximately 11:30. Before we begin, I would like to share a few housekeeping reminders. So this webinar is being recorded. If you don't wish to appear on the recording, you might want to turn off your camera. To ensure smooth communication, please stay muted while others are speaking. If you would like to interact or ask a question, kindly raise your hand and we will invite you to contribute. And finally, if you have any additional links or experiences to share during the discussion, please feel free to use the chat function. Thank you. So let me tell you a bit about this Circular Biocarbon project. Circular Biocarbon is a Horizon 2020 project running from 2021 to 2027. It brings together a consortium of 11 partners led by the Spanish utilities and waste management company Urbaser. So together, the partners combine their complementary expertise to develop a first of its kind flagship biorefinery. This facility aims to valorize two streams of urban biowaste, so the organic fraction of municipal solid waste and sewage sludge. The consortium offers a full value chain perspective, spanning from feedstock to intermediate products, or what we call building blocks, and further building blocks to added value end products. These end products include, you can see them on the right-hand side of your screens, various types of coatings, which we'll hear more about today, green graphene-based products, compostable bags, biodegradable mulch films, and a range of fertilizers. This comprehensive value chain approach also demonstrates a compelling business case for local and regional bioeconomies. It highlights innovative ways to generate value from urban waste flows, moving beyond more traditional biowaste to energy solutions. So at its core, this project seeks to unlock business opportunities through a circular economy lens. And in this value chain, local and regional authorities play a crucial role. They are typically responsible for waste and wastewater collection and often also their management. So by adopting circular approaches and embracing a biorefinery approach, these authorities can achieve economic returns that help subsidize the costly waste collection and management systems through new revenue streams alongside clear environmental benefits. But the role of cities and regions goes beyond waste management. Local and regional authorities can drive territorial bioeconomy strategies, incentivize circular practices, and catalyze markets for circular bio-based products through tools like public procurement. They also have the power to advocate for policy change and influence legislation, making them essential to the success of this approach. So as part of the project, we have a group of local and regional governments interested in the replicability of the project through a working group. This is the City Interest Group that I was referring to before. And October marked a significant milestone for the project with the inauguration of the first site of the flagship biorefinery in Zaragoza, in Spain. The biorefinery is operated by Urbaser under contractual agreements with the municipality of Zaragoza. This facility is actually the first of a multi-site approach with another biorefinery currently under construction on the outskirts of Milan in Sesto San Giovanni in Italy. This multi-site strategy will enable the testing of the biorefinery's performance in different waste management contexts, and of course will provide key results that will be fundamental to maximize the replicability of the project. And now, so you have heard about us, now we'd like to hear from you. We have prepared a short questionnaire on Mentimeter to better understand your experiences, interests, and challenges in the field of the bioeconomy. And I will try to share my Mentimeter screen. It should appear on the screen shortly. Should be loading. All right. Is it working for all of you? You will see now some options, and you can basically submit your answers to this question. Which category describes better your professional affiliation? I see some answers already coming. Right, so we have researchers, we have also waste management and wastewater companies, industrial partners, also some local and regional authorities, of course, industry. Well, so far, quite varied representation. Good. It seems that the other category is getting huge as well. Great. I think we can get a picture of the audience. Let's move on to the next slide. So here we would like to know about your interest and your current work. What aspects of the bioeconomy most align with your current work or interest? You will see some answers in the screen. I see a raised hand. It would be fine if you could write your issue in the chat, and we will try to assist you. Right. So many people working or with interest in circular bioeconomy strategies, also bio-waste valorization. Of course, this is a very key question, also considering the focus of the webinar. Innovators, technology developers, the territorial aspect of the bioeconomy as well. Please, could you mute? Right, thank you. Right, let's move on to the next question. So what is the biggest challenge you face in advancing bioeconomy related goals in your role? And I believe you will have some sliders here, and you can select one if a certain issue is not a challenge for you, and 5 if it's a big challenge. You have a series of potential challenges: policy and regulation, financing and funding, collaboration across the value chain, public awareness and education, and technology or infrastructure. Right. They are moving. I see varied responses here. Pretty similar degrees of challenge for all of them. Financing and funding seems to be on the lead, but they are all quite similarly positioned. I guess this gives us a picture of the actual challenges on the ground. This also resonates with our experience and with our dialogues with the stakeholders that we've been engaged with. Great. Now let's move on to the next slide. So what do you hope to gain from this webinar? You will have a box and you can type your answer here. You can be pretty open. We will leave around 20 seconds for this. Well, I see we get some responses already. So knowledge, of course, we will share some knowledge. It's an ideal opportunity for doing so. Governance ideas, yes. Effective business models. I think there is something about that as well. New ideas. Ideas is a big one. How to overcome barriers. We will have a discussion session later, and we'll have the chance to discuss this as well. Recycling, increased understanding. All right. Well, I think we have a pretty diverse set of responses. Sorry, I think someone just joined the meeting. Please mute yourself if you're not speaking. Thank you very much. As I was mentioning, I think we're getting a pretty diverse set of responses. We will have a discussion session later. And yeah, of course, you are free to raise your hand and elaborate a little bit more on your responses if you deem it relevant. Now we will continue with the webinar. So my slides should be loading. They're not, it seems. Yeah, apparently we have some internet connections here today, so everything's not running as smoothly as we were hoping for. Apologies for this. Right, should be loading. Great to hear from all of you and from the challenges, from the experiences that you have shared so far. We will have some occasion for dialoguing later as well. Please hold on. I think we will be retrieving our slides now. Wonderful, it worked. Right. So as I was mentioning, I hope today's topics are relevant to you and contribute to your areas of interest. Here in this diagram, you can see territorial circular bioeconomies, be it local or regional, with their natural resources, but also with residues that are valorized for maximizing environmental and economic impacts. This diagram also represents the different flows within a given territory, and by following the arrows that represent the flows, the diagram aims to showcase that biorefineries can become central pieces in opening up new opportunities for sustainable resource management at a territorial scale. From an environmental perspective, but also from an economic perspective, for example, looking at issues such as economic resilience of territories. Here, bio-based materials coming from valorization have much to offer to complement also some already more embraced bioenergy applications. So to fully grasp the importance of each component within a territorial bioeconomy, as well as the unique contributions of the circular biocarbon biorefinery to those, this webinar series has delved into a range of fundamental topics. These topics highlight not only the operational dynamics of the biorefinery, but also its broader significance for local and regional stakeholders, whether they are public authorities or private sector actors. So in webinar 1, we learned about how to set up organic urban waste-based biorefinery. We learned about the circular biocarbon biorefinery approach. We learned about the feedstocks and the end products, and of course we discussed about the barriers and the solutions to setting up such a model of biorefinery. Then biowaste, and specifically the organic fraction of municipal solid waste, constitutes a key component of the value chain. So it is also a material flow where local authorities and waste management companies have a crucial role to play. In webinar 2, we learned about good practices to improve the quality of this biowaste, so understanding biowaste as a feedstock, and questions around quantity and quality. Also, why should we aim at higher levels of purity, including the economic returns that this offers? Then we learned about what cities are doing to collect biowaste and how cities can really improve this collection of biowaste with examples from all over Europe. The next step, which we will be focusing on today, is the step from building blocks to high added value bio-based products. And it's a step with significant possibilities. So a vast amount of innovation is concentrated here currently. And I'm sure that the audience has also some examples to share. Just to give examples from the project, this opens up opportunities for all kinds of alternative and more sustainable products to their regular counterparts. So bioplastic, tailor-made fertilizers, precision solutions for moving parts, etc., benefiting sectors such as agriculture, manufacturing, construction, consumer goods, and transportation, among others. So in a few minutes, we will hear about Semicon's approach to obtaining bio-based coatings from biowaste, like the latest developments in bio-waste valorization approaches with a focus on bio-waste coatings, their applications, and also the value proposition in a bio-based economy. But of course, to ensure that this whole picture remains stable and delivers positive outcomes, it's essential to maintain the connections or arrows that you see on the screen. So how do we keep everything together? How do we keep the regional bioeconomies operating? The answer lies in a collaborative approach, one that involves both public and private sectors working together to shift the playing field and enable the transition to circular bioeconomies. So several instruments can be put into place to facilitate this process. Here, raising awareness and building capacities are crucial steps. Localized pilots must be scaled up and replicated, and various actors need to establish dialogues to tap into the opportunities that these approaches present. So I believe this resonates with many of you. In practice, this could mean leveraging the governance and policy instruments, mobilizing local and regional authorities, but also beyond by adopting a multi-level governance approach that engages other levels of decision-making. So for example, this could involve developing local or regional bioeconomy strategies or roadmaps and advocating for changes in policy. From an incentivization and public-private cooperation perspective, the public and private sectors can collaborate by offering targeted support, participating in joint research, and generating demand for circular economy solutions through public procurement. Additionally, hubs and clusters are increasingly becoming key instruments, as are also physical spaces for exchange of energy and resource flows, such as those in industrial symbiosis. This is, of course, a non-exhaustive list of examples. Later, we will hear from Pierluigi, who will share how they maintain this whole picture together by fostering a regional collaboration through hubs and policy innovation. So that was it from me. Now we will hear from Michael Pham from Semicon. Michael, the floor is yours. Thank you.
Thank you, Nestor. I just need to make my screens work, and then I will share my presentation. 2 seconds. So I believe you can see my screen now.
Yes,
we can. Yeah.
Brilliant. 2 seconds, then I have all the technical stuff worked out. Good. So yeah, thanks for the nice introduction, Nestor. So I'm Michael from Semicon. I am Chief Technology Officer in Semicon Scandinavia, and we are a partner on the Circular Biocarbon project, which aims at turning carbon into, well, value-added products. And this is carbon from complex organic waste streams. So we are an end user in this product, or in this project, and our role lies in showcasing that what we can use these building blocks that comes out of the biorefinery for. In this webinar, now it works. I will briefly touch upon who we are. In Nestor's presentation, you gave a bit of feedback where you come from, and the audience is a bit, there's people from a lot of different places. So to set the scene for who we are and how we work, I'll give a brief introduction on that, then our solutions, how we create value. And then I will go in deep into the project, where we are right now, and the current results, and then the outlooks and what will come in the next periods of the project and where we see this going. So briefly about Semicon Scandinavia. We are based in outside Aarhus in Denmark, where the red dot is on the map. We were founded 20 years ago, and we provide advanced surface treatment for the industry, along with doing consultations and R&D. We are today 25 employees and have approximately 400 customers across Europe. And our company has been among the pioneers in physical vapor deposition coatings for advanced injection molding tools and components. So just our company structure is a bit, well, not like most companies. So what we do, the main part of the company is that we provide coatings for our customers. Our customer sends us parts and we coat them and send them back. I'll get a bit more into that later. But then we have 7 people today working full-time on what we call research and innovation activities. This means that we do internal development to create the next coating, the next service that we can provide to our customers, but we also provide consultancy assisting our customers in optimizing their production using coatings. We analyze other coatings, we analyze surfaces, and we have a large focus on replacing old technologies. We have a large focus on hard chrome plating replacements, as well as avoiding PFAS. And then the last leg is what we call external projects, and this is where we find the Circular Biocarbon project, where we work together with our partners and the funding body, in this case, the European Union and the CBEJU. And the idea is that we can contribute with our knowledge and, well, build value not only for us, but also for the entire value chain that we are part of in this project. So the main customer for us is an industrial customer. In principle, it can be any customer. It can be a customer who produces cutting tools for them, well, just for selling them or for using them for the metal industry. It can be forming tools for metal forming applications. It can be for tableting tools for pills, pharmaceuticals. We have a very large focus on molding tools, primarily for plastic molding and injection molding, as well as extrusion tools for the plastic industry. And then we have this last box that we call components. In principle, components is the rest. This also includes direct consumer products. Our coatings have been developed primarily to have a function. They happen to have a color. And many of our, let's call them colleagues or competitors, they have a vast focus on doing PVD coatings for decorative purposes. So our customers, they simply send us some of their tools, and we take the tools into our facility where we treat them with physical vapor deposition. So using highly advanced machines under high vacuum, we evaporate metallic atoms, or we evaporate metals, and we mix them with reactive gases. And in that way, we are able to build a coating more or less atom by atom. And in that way, we can define the structure of the coating. And with a thickness of between 1 to 3 microns, we can achieve great results on the parts that we coat. I don't want to go too much into detail about the technology because I don't think that will create value. But what you can see on the right side of the screen is a cross section of a coating. You can see that it's dark gray in the top, and you have these arrows indicating where the coating stops and starts. And underneath you have the substrate. Important for us is that we have an excellent adhesion to the substrate. And then we have 25,000 parameters we can vary in the coating unit and build specific coatings based on this. This is developing new coatings is quite close to fundamental research, and it is a very exciting field. In relation to the circular biocarbon, and I'll get into that later, we build this up atom by atom. So when you have too many, let's call them unwanted materials or impurities, then this may cause a challenge. Anyway, when we have coated the parts, we send them back to the customer. Depending on the customer, we will create value for this customer in different ways. Traditionally, the coating has been used for cutting tools, and here the main value that you're looking for when you want to coat a tool is the lifetime of the tool. On average, you see an increased lifetime of a cutting tool with 20-fold applying a 3-micron coating. But when you look into other industries, such as for example, the plastic molding industries, we start to see some very interesting effects for our customers. We see that the customers, they have the opportunity to reduce the electrical consumption of the parts that we coat, from the uses of the part we coat. This is primarily for plastic molding tools. The electrical consumption can be reduced because process parameters can be optimized. This contributes furthermore with a reduction in CO2 emissions per part produced for most of our customers. Also, the quality of the parts that come out is in general higher, which means that the scrap rate of the parts the customer produces is lower, which again decreases the environmental impact that this customer has on the environment. Most significantly, we reduce the required maintenance. This means that many times the service interval for the tools that are coated, they can be increased 4 to 5-fold. And very interestingly, when you optimize the processes that uses the tools after coating, we see that you can increase the productivity with 5 to 30%. So our customers, they can save resources and emissions. They can improve their production and have much less maintenance at a very low cost compared to the price of the tool. As an example, here is the drawing on the right is a drawing of a similar tool. The picture is not from this tool because I do not have pictures of this exact tool. We have a customer that had a problem. They are a tool maker, and they produce the ejector pins. The ejector pins are these black rounds sticking out of this mold, and they are producing a medical item. And the tool maker needed to guarantee 2 million shots in total. And this is a molding tool that produces 128 parts for every shot. So the tool maker needed to guarantee that the tool would be working for 256 million parts. However, after 1 million shots, the ejectors, they were done. After coating with our DLC, they could run completely without any lubrication. And after 20 million shots, there was no visible wear on the parts. So we've seen a lifetime increase of 24, which is a very good example of how a 3-micron thick coating that cost nothing compared to the manufacturing cost of the tools can increase the performance and increase the lifetime of a tool. So that's a bit about our core business and how we work and how we create value for our customers. So in the Circular Biocarbon project, as Nestor already told you, we have this biorefinery that is, well, we have 2 sites, and the biorefinery will create building blocks that will be used for different end products, where our parts are these highlighted in the top. So we have direct consumer products, mechanical moving parts, and plastic molding tools. These are examples of what we do and how this coating will be used. So our aim and our role is to show that we can utilize these building blocks to produce functional coatings. And just imagine, so talking about plastic molding tools is a bit, for people not involved in that area, that can be a bit far-fetched and difficult to follow. But imagine that in 3 years, we will be able to produce this black color on all these products based out of the raw material that you see on the left side of your screen. I find that quite amazing. The DLC coating that we produce, it's an abbreviation of diamond-like carbon. So we can actually create diamond-like structures out of banana peels, whatever you throw out in your bag, oranges as well. So this is how we see the future, that these coatings in the future will be based on building blocks that are produced out of, in this case, this picture, the organic fraction of the municipal solid waste. So how do we make this happen? Because there's a clear reason why everybody is not doing this already. That's because it's not trivial. So we have the biorefinery that are producing the building blocks, and we will be using these building blocks. However, when you deal with biological processes, you'll always have, let's call them uncertainties. Right now, we had the inauguration of the biorefinery in October. So the building blocks has slowly started to move in our direction, which means that our current experience in using these building blocks is still quite limited. However, we expect that whatever comes out of the biorefinery, at least in the beginning, will have some variance, and it will be a great job to figure out how to deal with this variance in the quality. So what we'll be doing is that we'll be monitoring the quality of the building blocks. Internally in Semicon, we'll be working with 3 handles. We want to optimize the processes that we use to be as good as possible. We want to make the process design as robust as possible and to reduce the tolerances as much as required. Today, everything needs to be perfect in principle, but there has not really been any significant analysis of how low you actually can go in quality and still have a good product. So in principle, we make this type of wheel where we design an experiment. We manufacture the coatings based on the building blocks. Then we do some measurements, analyze, and then we draw some conclusions. This may lead to feedback to the guys in Zaragoza if there are anything that we have a challenge with. So to see if we can somehow adjust the building blocks, or if we need to adjust our processes. And the aim here is that we can broaden our, let's say, the input quality. So we can produce good coatings despite lower quality of the input material, because this is what we expect. Today, all the materials that you use in this industry, they are based on on oil and gas industry, and here everything is perfectly clean. So this is how we work on this. When you work with coatings, you have a few let's call them topics that you need to assess depending on the application of the coating. So first of all, you need to make sure that your coatings stick. Then you also need to make sure that it meets the requirements that you have for the function, and maybe application-specific properties. In the PVD coating world, we use a method where we do an indentation with a diamond, and then we look at the crack formations around this indent. And I will give you a sneak peek into some of the first data that we have gotten from this from the work in the project, where we have 3 different types of building blocks here, and we have A, B, and C. Here we see an indent from the top of the batch, from the middle of the batch, and from the bottom of the batch. So you can see that under A, the lowest one, you have a lot of, let's say, non-black area, shiny area around the indent. This means that the coating is falling off, and therefore we've placed a sad smiley underneath, because this is not what we want. However, with 2 of the other options, we actually see that we have decent or excellent quality already. So from an adhesion point of view, we actually already quite happy about the situation. The next bit that we do is a let's say a visual inspection. Don't be frightened by all the things going on the screen. This is a representation of different things that can go wrong when you build a PVD coating. Most of the things, they are related to the substrate, but the option C, option F, and option G comes from failures in building the process. So these can originate from process errors, machine errors, or from impurities in the building blocks. And this we do not really have much data on yet of the work in this project yet, but you can see some of the pictures here. They are representations taken from a scientific paper. It can have detrimental effects on the coating if you have too many craters or too many pinholes in the coating. So this is some of the things that we are evaluating and monitoring. The next bit is we call this a functional analysis, where we do scratch testing. So what we do is we take a very small diamond tip and we force it into the surface of the coating, and then we scratch it along and increase the force. And doing so, we can have an evaluation of the coating adhesion. And on the right, you see an increasing, let's say, LC3 value. I know I'm out of time soon. But what we can see is that we have done some different iterations and modifications, and we have been able to push the adhesion quality of the coatings quite far already. Just as my last slide, we have the current state is that we have a fully functional system already that is ready to take these building blocks, and we have some very promising initial results. The biorefinery has just been turned on, so in a year we will have a lot more very interesting results, and hopefully also we will see some variation, so we have an idea about where the input quality will be. We have already improved and broadened our process window. So the next thing for us is to accelerate the work with the building blocks and validate that our coatings, they work. The idea here is we see ourselves as high performance users of materials. And this means that if we can use these building blocks, most other companies with lower quality requirements can. So the idea is to showcase that we can use the building blocks in practically any industrial application that uses these building blocks already. I know that was 21 minutes. Sorry about that, Nestor.
Perfectly on spot. Well, thank you, Michael. Great to learn what Semicon is able to achieve. This is a good example of the products that circular biocarbon approach is able to achieve. And now, do we have any questions for Michael? Please raise your hand if that's the case.
I can say so much that if there are no questions, I could talk forever, but I won't.
There are
There is a question in the chat. Yeah.
Okay.
So it's basically on what substrate building blocks do you supplement with the biowaste? And then also a reflection on the ecological impact for Semicon.
So the substrate that we have used for the test this far is tool steel. So we use steel grades that are identical for what you would use when you have the coating. So plastic molding, tool steel, or high-speed steel. These are used for these tests. The impact for us is well, we are working on defining that. One of the partners on the project, that is UVic, I believe. They are doing analysis of how this affects the footprint that we have. And the initial calculation says that going to a circular carbon source will lower the CO2 equivalent with, I think it's somewhere between 25 and 30% for our production, which is actually quite significant.
Great. It is indeed significant. Do we have any questions? I think you were very clear, Michael.
I can say that someone said that they wanted to hope to learn about graphene, and unfortunately, I didn't say anything about graphene. In the coding area, we have Graphenea as a partner as well, and they are the experts on graphene. And I will be happy to give a summary, but they will be much better in this in another case. Yeah.
Yeah, let's see if we can help them for future occasions. There is another question in the chat. So can you tell us something about the energy consumption of the process?
Yeah, the energy consumption is quite high. It's quite dependent on the exact coding that we make. And the consumption also should be seen in relation to the batch size. So because we do the coding under vacuum, it's a batch process. We fill the chamber, close the doors, and press start. And then depending on the coding, 5 or 12 hours later, the doors open again. We have high temperature processes and low temperature processes. The electrical consumption for one process is between 50 to 200 kilowatt hours. So it varies a lot. We are working on reducing these, but I don't really have a good answer to what it is in general. And the batch, depending on how big items. If I have really big plastic molding tools, I can have one part in the coating unit. In other cases, I have 20,000 smaller parts. So the amount of electricity used per part is quite difficult to say. It is an energy intensive process, yes. But luckily, electricity is one of the areas where we have options of choosing, let's say, green alternatives. Building blocks is worse. The accessibility of environmental friendly produced building blocks is much more scarce.
Great, thanks, Michael. And we are taking one last question. This is a very interesting question coming from the city of Warsaw. They are also part of the City Interest Group of the project. And the question is, how attractive is this solution, not only in terms of waste management, but to what extent can be an alternative to obtaining materials?
Oh, very interesting, if you ask me. From my point of view, us and Graphenea, we build coatings atom by atom. And if we are able to use this material to build high-end products, everybody who has the ability to use the same building block. So this is just a simple carbon source. If you use carbon somewhere in your production, this should be a possible, let's say, building block to use. So that is actually, I ran out of time, but that was what I was trying to explain in the last slide, that if you have lower requirements to the quality than we have, you should be able to use this. And as I see it, most industrial companies that uses carbon, it could be that they produce carbon black for coatings. It could be other coating types, or even carbon sources for lubricants. I see that they could potentially use a circular carbon source from, for example, this biorefinery, or a copy of it. I hope that that answered the question.
Wonderful. Thank you, Michael, for your contributions and your reflections. Now it's Pierluigi Argonetta's turn for the second part of the webinar. So we will learn about regional collaboration and the role of hubs and policy innovation. It's all yours, Pierluigi. Thank you.
Okay, can you see my screen?
It's loading. Yes, we can see
Okay,
it.
perfect. Good morning, everyone. And first of all, let me thank the organizer, Nestor, and the whole team of this webinar for inviting me to speak. It's a pleasure to discuss how the BioINSouth project contributes to advancing regional bioeconomy, particularly through innovative approaches like biowaste valorisation. My participation here is really important because BioINSouth aligns closely with the objectives of this webinar, and transforming biowaste into high-value bio-based materials and driving sustainable development at urban and regional levels. What is BioINSouth? BioINSouth is a CSA, a coordination and support action project founded by CBEJU. CBEJU is a 2 billion partnership between the European Union and the Bio-Based Industry Consortium that funds projects advancing competitive circular bio-based industries under Horizon Europe, the EU's research and innovative programs. BioINSouth is a collaborative project. It involves 9 different countries and 15 partners, each offering specialized expertise and resources to achieve our objectives. We are proud to collaborate with leading university, research institution, industry association, and innovation hubs from across Southern Europe and beyond. Together, we are working to establish regional hubs in 8 different Mediterranean regions, each with unique challenges and opportunities in the bio-based economy. These hubs are central to fostering collaboration and implementing sustainable bioeconomy solution. Among these 15 partners, of course, there's Spring, that is the Italian Circular Bioeconomy Cluster, which is the coordinator of the project, and also a key player in advancing bioeconomy initiative both nationally and internationally. Spring operates on 2 primary fronts. The first one is the dialogue with policymakers. We have a lot of permanent working group in the Spring regions. We participate in national coordinating group of bioeconomy. We provide also expertise to upload to improve the implementation of regional RIS3 smart specialization strategy, and we work with CBJU. At the same time, the second front that Spring has is the development of the bioeconomy, and that's why we participate in several European projects like BioINSouth, Rural BioUp, and many others. The focus of the project BioINSouth is support decision makers in integrating ecological considerations into regional strategies for circular bio-based activities. This includes not only, of course, addressing environmental impact, but also creating practical roadmaps for sustainable growth in bioeconomy. This is a comprehensive overview of the BioINSouth project. As you can see, we have 7 different work packages. The first one is the management work package. The last one is the communication and dissemination. And then we have other 5 different work packages. And I would like to show you in the next slides a little bit more deeply the organization of the project. One of the main goals of the BioINSouth project is the creation of this group of people, the multi-actor regional groups, MARCs, These groups, consisting of representatives from the quadruple helix, academia, industry, government, and civil society, will serve as the foundation for the hubs. They enable stakeholder engagement and collaborative decision making. The project BioINSouth started last June, June 2024. We are now running in the 7th month of activities, and we already established these 8 marks in 8 different regions. This was our first milestone, and we met it just a few days ago. Then the second goal is the establishment of the 8 hubs. We have to establish these 8 hubs across the Southern Europe, South Europe. And we are inspired by the success of the BioEast initiative of the Czech Republic. So each hub will develop tailored action plans and will act as a one-stop shop for promoting circular bioeconomy practices. As you can see in this slide, the 8 hubs will be established by June 2025 in Italy, in Campania region. The coordinator will be Spring. Then in Greece, in the region of Peloponnese. Then 2 hubs in Spain, in Andalusia and Asturias. Then 1 in Portugal, Centro Region, and 1 in Slovenia, 1 in France, Nouvelle Aquitaine, and 1 in Cyprus. What are the key points of these hubs? Mainly, we have to consider 4 key points. The first one is that the hubs will be designed to support local bioeconomy development while aligning regional priorities in agriculture, forestry, and marine sectors. This ensures a tailored approach to each region's unique needs. Then we will like to consider this hub like center of innovation, providing technical expertise and creating actionable methodologies that stakeholders can adopt to enhance their bioeconomy strategies. Then again, the hubs will act as a facilitator for sustainable practices, leading commercialization efforts and fostering partnership with academia. And lastly, the hubs also will offer policy recommendation, secure financial support, and work to facilitate regulatory frameworks, making the adoption of bio-based solutions more accessible and impactful. There is another key deliverable that is really important considering this project, that is the realization of a toolkit for the assessment of environmental impact and circularity in bio-based systems. These toolkits will provide an in-depth understanding of bio-based processes at regional level, ensuring that local challenges and opportunities will be effectively addressed. Then the toolkits will evaluate the circularity and environmental impact of bio-based activities, helping stakeholders identifying ways to optimize resource use and reduce ecological footprints. And then this toolkit will offer actionable roadmaps, guiding stakeholders in recognizing and leveraging existing and emerging bio-based opportunities in their region. It is really important for BioINSouth develop policy recommendation and at the same time designing a replication strategy of broader implementation. So the recommendation will integrate the environmental impact assessment and circularity monitoring systems, ensuring that sustainability and circularity will be the core of regional bioeconomy strategies. And then the replication strategy will be developed inside the work package 6, taking into account the successful element of the BioINSouth hub models. These slides showcase the transformative impact of the BioINSouth project. It summarizes more or less what I said until now. And so you can see the 4 key pillars of the project that are the hubs, policies, toolkit, and the replication strategies. Let me conclude with some consideration about how BioINSouth could interact with the biowaste valorization. First of all, we have to consider that BioINSouth will establish these regional hubs that act as engines of bioeconomy initiative, focusing on innovative solutions, also considering biowaste valorization at both urban and regional level. Through MARS and hubs activities, BioINSouth fosters collaboration between industries, promoting also the use of biowaste as a valuable feedstock for bio-based material production. Additionally, the project will develop strategic recommendations for policymakers aimed at encouraging innovation in bio-based materials and creating a supportive regulatory environment. And finally, BioINSouth brings together stakeholders, including local authorities, businesses, and academia, to exchange best practices and co-create impactful solutions also for biowaste valorization, ensuring a collaborative and sustainable approach. At the same time, BioINSouth could play a vital role in advancing the bioeconomy transition by addressing key challenges and leveraging strategic opportunities. We will develop a comprehensive toolkits and guidelines to support stakeholders in evaluating and implementing biowaste valorization strategy effectively. And this ensure that stakeholders have a practical resource tailored to their needs. And then the project adopts a strategic approach to ensure the continuity of bioeconomy initiatives behind the project's duration, making its impact long-lasting and relevant. That's why, through partnership with other bioeconomy-focused projects, BioINSouth try to amplify its reach and effectiveness. This collaboration creates valuable synergies that enhance both regional and urban economy ecosystems, ensuring broader benefits for all involved stakeholders. Before to conclude, I would like to share with you about the BioINSouth Forum. The BioINSouth Forum will be realized on the next June in the city of Catania in Sicily, in South Italy. And it will represent, in my eye, a pivotal event in advancing the circular bioeconomy across Southern Europe and the Mediterranean region, also as a bridge to the north countries of Africa, maybe. This forum will be held in Catania, I said, in 2 days. And here will convene key policymakers, academics, industry leaders, and also regional stakeholders to foster dialogue, share best practices, and explore innovative approaches to bioeconomy implementation. I would like to anticipate to you a draft of the agenda. We will be our guest, a previous partner of the project that now it has been named as EU Commissioner for Fisheries and Oceans, Costas Cadiz. It was one of our partners and now is a EU Commissioner for Fisheries and Ocean and will be present at this first forum of the project. Then we will have Virginia Pozzolo from CBJU and many others interesting people from all the consortium, of course, but also from other European projects. Thank you for your attention. Thank you for inviting me, and I encourage you to follow BioINSouth on LinkedIn page and also on our website to remain to follow our activities and for updates on our progress and impacts. If you have any question, I'm here, and thank you again.
Thanks, Pierluigi. The date is duly noted. Also, thank you for the presentation. This was very illustrative, very interesting. This last reflection on how the project addresses biowaste valorization as well. And yeah, a very promising project, and I wish you and the team all the best. And I'm sure the audience will be interested in following the progress as well. Also very interested on the policy recommendations myself personally. All right. Do we have any questions for Pierluigi?
Yeah, we are just at the beginning. It's not really, that's been not really technical speech, but I think that it's a synergic point of view that could be useful for both the initiative. If you have any question.
Yeah, definitely. I think these are like two complementary approaches to the same topic, looking at different sides, but also with the potential of building many synergies. Any volunteers for questions? Otherwise, I can maybe ask one. So yeah, Pierluigi. So one of the common themes of our project, so beyond the obvious theme and the synergies around the bioeconomy, is like the Southern European focus, also for the two biorefinery plants in Zaragoza and in Sesto San Giovanni. Do you think there is any specificity that defines these regions, like generally, but also specifically when it comes to valorizing biowaste? Is there anything, any characteristic?
Yeah, I'm quite sure that we can find some strong synergies because I sure can create a link between these two biorefineries with the marks that we already created in these regions, and maybe they can find some something to talk about how to concretely interact in that nation and that region. Consider that, so we are at the beginning, but in the next 6 months, we have to create these hubs, and these hubs have a target of at least 15 organizations inside the lab, at least. So it will be really open to interact with other people and organization in this region. And I think that the dynamics of the hubs will be really focused on the regional level. And so I think that they could find a good way to create synergy. So there's no limitation from now.
Great, perfect. Thank you. So then I think we can move on. Well, I believe there's another question in the chat. So yeah, can you give concrete examples of your products? I guess that the outcomes of the project, the policy recommendations. And...
Yeah, not yet, because we started a few months ago. One of our goal is this is not a research project, it's a CSA. So we would like to create this toolkit. First of all, we would like to create these 8 hubs. It is not easy, as you can imagine. And each hub will have to interact with the regional level, also with the local minister at regional level, to try to give them some inputs about bioeconomy development in that regions. And this is a great goal for us. Then there will be a toolkit. And at the same time, you have to consider that now we are in the 7th month of activities. We already have another country, Turkey, that maybe will create an hub as a good spin-out of our project. We are just at the beginning, but there's already another country that it was not comprised in the project at the beginning as a country in which we will have to realize an hub that won't create an hub. So I think that it could be really important also this output to create this hub in another region that originally was not included in the project. But now we are just at the beginning, and if you follow us or if you want to interact with us in the next month, starting from January, I think that will be some more concrete I can share with you.
Great, thank you. Yeah, duly noted. So I think that's it for the presentations. Now it's time for the open discussion. Here we would like to address wider topics in connection to both presentations before, but also regarding regional bioeconomies and the role of biorefineries and bio-based products more in general. And this is an open floor for all of you. But maybe first I would like to hear from cities, as I believe we have some in the audience, as we saw in the Mentimeter before. Also some that are part of the City Interest Group. Any cities or regions that would like to share your experiences in setting bioeconomies or the types of bio-based materials you have explored, your waste valorization approaches? Do we have any reactions? Does this resonate with you? No reactions? Yeah, don't be shy. All right. Well, maybe it was a lot to process. Maybe we can also keep this conversation offline. If there are any pressing issues, we can tackle them offline as well. Yes, of course, you can also leave your reactions in the chat. We will be happy to read them out. Any other reactions coming from cities, but also other kinds of partners, industry partners, stakeholders? We are curious to hear from you.
Hello, this is Johanna from Mikkeli.
Hi, Johanna.
Yeah, I did get some questions in advance about the biorefineries and such. And thank you very much for this webinar and the presentations. It was very interesting. If this is the place for me to tell about Mikkeli, Finland?
Sure. We would be happy to hear about your experiences. Go ahead.
Okay, so you had some questions about advanced biomaterials. Is Mikkeli working towards producing value-added materials from the valorization of biowaste? And answering these questions, yes, we do have a biorefinery which was made in just about 4 years ago. It produces biogas for the use of cars and trucks. And from these side streams of the biogas production, we capture the nutrients from the liquid reject, and then we make fertilizers from that. And then we have some cooperations with stakeholder companies, and they are developing the side stream material uses, and mainly it's about fertilizers. And we do make some mulch products. And then there was questions about the bioeconomy strategies and initiatives. Does Mikkeli have bioeconomy strategy in place, and is the city promoting the bioeconomy through the dedicated strategies and industrial symbiosis. So we do have a bioeconomy hub called Ekosairala in the city. So we are a small city, about 52,000 inhabitants, and we are looking for further treating the biological and technical materials flows in the Mikkeli region within this Ekosairala hub. And we have a wastewater treatment plant utilizing very advanced purification technology. And also we have a modern, diverse waste management center and of course the biogas plant within the same area, and it is within the Ekosairala hub. And of course, we're looking for further business opportunities and synergies within companies and other actors located in the area. And for example, the biorefinery uses the sewage sludge from the wastewater treatment plant as raw material as well. And I suppose we are developing a coherent we're looking to develop a coherent bioeconomy strategy, but we do not have one at the moment. We have, we're mainly using like smaller platforms like within projects like Green Economy Mikkeli, and we're looking into the Green Deal work and how to use those to develop this bioeconomy strategy. But yeah, I suppose we would like to see examples from those and perhaps benchmarks other bioeconomy strategies from small towns, or why not bigger ones as well. Then there was a question also about challenges and barriers, what obstacles we have had in these areas. Of course, getting finance into this work, since we are a small town, it is a bit tough. We're doing a lot of this development work through projects, smaller projects, and that might be tough sometimes to find the finance to do it. Then also, just to be concrete, when we were building the biorefinery in Mikkeli, it was budgeted well below for what it was in the end, the cost. So yeah, to make the refinery viable today, 4 years after the building, it is a bit difficult. So there's some challenges there. Also, there's been challenges in the mulch products made from the biowaste, specifically the household biowaste, and the usage of that material, because there are small plastic particles in the material, and there has been a lot of news related to this issue, that we don't want those plastic materials in our grounds when we are growing food for ourselves. So that's one thing, how to get the plastic out of the household biowaste materials, and how to do it effectively and not in an expensive way. So those are some issues and thoughts from me for now. Thank you.
Great, Johanna. Thank you very much. That plastic problem is a problem, a huge problem, and something that also some other cities can share, and I'm sure they share. So yeah, I mean, wonderful. Thanks for sharing your first-hand experience in Finland, also in a smaller city with of course, like the smaller you are, the more limited resources you have. And I think this is very valuable also to hear from your experience, and to see that nonetheless you have a very comprehensive approach of setting up a bioeconomy model involving a biorefinery that I'm sure it could be a good case to study also for other cities. I don't think we have any more cities. Besides cities, if anyone else just wants to say something very quickly, reflect on Michael's presentation, Pierluigi's presentation, leave examples, you're all very welcome to do so. Otherwise, I think we can wrap up. Yeah, I see a raised hand. Simon.
Yeah. Okay, can you hear me?
Yes, we can.
Okay, great. Maybe this is a question that connects what Johanna just said about kind of plastic residues in biowaste and Michael's presentation, because I guess they pyrolyze the biowaste before it's, I don't know, carbon black or whatever your original material for the diamond-like carbon coating process is. And then I guess it's not a problem to have like organic residues, plastic residues in the biowaste, right?
Do you want to take this one, Michael?
Are there anyone from Urbasa here? I think they would be more deemed to answer that question. The entire cleanup process and dividing into different building blocks is out of my hand. I only give feedback on whatever is left in it. There is, as I see it, no chance of having plastic waste in the building blocks that I get. I can see that, for example, the fertilizers, there might be something, but that I really don't know about. I would not be the right to answer that question.
Unless someone from Urbasser wants to answer this question, maybe we can write it down and we can provide a response in the follow-up email to this webinar. All right, so I think we can wrap it up here. Let me share my slides. Let's see if they are collaborative. Otherwise, yeah, I would like to thank both speakers, so Pierluigi and Michael, for your testimonials today. Also, thanks to you all for tuning in for the occasion. Yeah, it seems the slides are not working, but it's not a big issue. So the next and last webinar on this series will be communicated through the usual channels. For updates on circular biocarbon, keep an eye on our communication channels. We also invite you to follow the latest from Spring, also the BioINSouth project and Semicon's efforts. Finally, you can share your thoughts on the event by clicking on the feedback form that my colleague John left in the chat. And yeah, thank you all and have a nice reminder of the day. Thank you very much.
Thank you.
Thank you.
Bye.
Thank you. Bye. Bye.
Bye-bye.